All right, in this section, we're going to be talking about 3.3 factoring special polynomials. And some of these you have seen before, and so we're just introducing a few new properties. Something to keep in mind is that factoring means breaking it down into pieces, right? You're taking out common factors. There's a few things you should always remember, even though we are doing some new types of factoring. You should always look for a greatest common factor to factor that out first before you continue with the properties, okay? So the first one we have is difference of squares, and you have seen difference of squares before. We have two perfect squares with a minus in between them, and we split them up into one being a minus, one being a plus. Okay, so I'm hoping you are familiar with this. We have gone over this before in class. Most recently, we learned about sum of squares, where again we have two perfect squares, but this time they have a plus in the middle. And in order for that plus to work out, that means I have to have some imaginary numbers. So the only difference between sum and difference of squares is that sum of squares requires imaginary numbers, but you still do it the same way. One is minus, one is a plus. Now, here are the two new factoring. So the sum of squares, sum of two cubes, now we are adding, but we're adding cubes. So instead of being perfect squares, like the square root of 16 is 4, now we're asking you for the perfect cube. So what number multiplied by itself 3 times instead of 2 times is going to give you this number, okay? So we have perfect cube. So some examples of a perfect cube would be like 8, because 8 is made up of 2 times 2 times 2. So that's an example. Now, this is how we're going to factor sum of cubes, and we're gonna learn how to use that here in a second. And then lastly, we have difference of cubes. So again, using the cubes, perfect cubes, this is a plus for the sum, and then this is a minus for the difference, and then you're gonna just substitute into this property of factoring polynomials, okay? So again, you should be familiar with difference of squares and sum of squares. The only difference here is when we have perfect cubes. So let's go ahead and jump into the examples here. The first example we have is x cubed plus 64. So the first thing you want to do when you get to a problem is identify, okay, what kind of special factoring is this? My first hint here is that this is a cubed, so I'm obviously not going to use either difference of squares or sum of squares. I'm going to be using sum because it's plus. That means sum of cubes. Okay, so I have to first identify what my A and my B are. Okay, so I want to identify A cubed. A for me is going to be x, because if I were to substitute in an A here, this is part of my formula, A cubed. Okay, so A comes out to be x for me in this case. And then my B, so plus what cube? So I have to figure out what the cube root of 64 is. And you can definitely do this in your calculator using the math key, but you're looking for this function, the cube root of 64. If you can't think of it, use that calculator. So we're looking for the number that multiplied by itself 3 times is going to give me 64, okay? And hopefully, once you use the calculator or think about it, it's going to be 4. So A is going to be x, B is going to be 4. I'm going to go ahead and write down my formula, my special factoring. A squared minus AB plus B squared. And I'm just taking this from up here in the pink, okay? And then this is just a substitution, you guys. So that's why it's important to identify your A and B at the beginning, because then you just substitute and simplify. So what is A? A is x, plus B is 4. A again is x, but this time I'm going to square it, minus A times B would be x times 4. And usually we would like to write that as 4x, plus, and then B squared. So B squared would be 16. Okay, so this is you completely factoring x cubed plus 64. That is your factor. Okay, so it's going to be a longer factor. At the beginning, I did do this, but I didn't mention it to you guys. I checked for a greatest common factor before I started applying the rules, okay? So always check if there's a number you can take out before you can start multiplying it through. All right. Going on to number 2. Okay, so here I'm deciding if this is going to be something related to squares or cubes. Okay, so is it a multiple of 2 or a multiple of 3? Essentially is what it comes out to. I'm first checking that I can't take out any greatest common factors. So like they don't have a 2 in common, a 4 in common, and a 5 in common, anything like that. And then I'm going to say, okay, well, I see a difference because that's a minus. Okay, so if I go back up to my options, I have 2 types of differences. I have difference of squares and I have difference of cubes. So this particular problem doesn't have anything being cubed, so I'm going to have to use difference of squares, okay? So I need to split up this term into something that multiplies by itself twice, okay? So think about taking out that squared. So what squared would give you 16? Hopefully you're thinking 4. So 4 squared would give me this 16 up here. And what squared would give me x to the 4th? Okay, hopefully you're thinking x squared. If I were to distribute that exponent back in, then I would get the previous step, which is 16x to the 4th. I'm going to bring down my minus. And remember, your difference of squares is a squared minus b squared. So I'm here, my b squared. What number multiplied by itself? So what squared gives you 625? And hopefully you're thinking 25, okay? So in this case, your a is 4x squared, and your b is 25. Okay, so I'm going to go ahead and write down my formula here. I have a squared minus b squared equals a minus b, a plus b. So I have my a, I have my b. Now I'm just going to put it into my formula. So a happens to be 4x squared minus 25, and a plus b, so 4x squared plus 25. Okay. And then I'm going to try to see if there's anything else I can do to factor these. Is there anything else I can do to factor these? Looking at these again, I have 2 perfect squares here again, okay? Because 4x squared, if I were to break that up, isn't 4x squared the same as 2x times 2x? And isn't 25 the same as 5 times 5? So this actually became another difference of squares. So I have to do factoring again. This 4x squared becomes 2x minus 5, 2x plus 5. So again, thankfully, you are familiar with difference of squares, we hope. And then this right here, same exact number, so I know they're perfect squares. But because it's a sum of squares, I know that I'm going to split it up as 2x minus 5i and 2x plus 5i. Okay, now that I get to this point where nothing else can be simplified, I know that I'm done. So this factor, starting with this 2-term polynomial, now I have 4 different factors. Okay, I was able to factor it out into 4 different terms. If we go back to check the first one, there's nothing else I can do with this factor right here. Okay, that's why I didn't factor it further. But you do always want to check to see if you can do anything else to factor it out a little bit more. Okay, so number 3 is going to be very similar to number 2. You're going to figure out what squared gives you 16x to the 4th. So kind of work backwards and like, what squared gives me 16? What squared gives me x to the 4th? And then minus, again, what squared gives you 81? So I want you to pause here and try it. Try something and then play again. Once you're ready, see if you're on the right track. Okay, I'm really hoping you took the time to try it here. My 16, if I did 4 squared, I would get 16. If I would do x squared, I would get x to the 4th because those exponents multiply together, okay? Over here, I have 9 squared. So 9 squared would give me 81. So again, in this case, my A is 4x squared. My B is 9. And I'm writing down my formula. This is a difference of squares again. So A squared minus B squared. A minus B, A plus B. Okay, so I know what my A and B are. I'm going to substitute those in. A became 4x squared minus 9. And then 4x squared plus 9. And I run into the same situation where my first factor can actually be factored out a little bit more. This is a difference of squares again. So if I were to break this up, this would be 2x being squared minus 3 being squared. Okay, so when I factor this a little bit further, I'm going to follow the same formula. 2x minus 3. 2x plus 3. And then I'm going to do the same thing with this one. This time it's a sum of squares, so I know I need some imaginary numbers. So I have 2x minus 3i and 2x plus 3i. And again, this 2-term polynomial factored out into 4 factors. Okay. All right, let's go on to the back side. Okay, so here we have 8x cubed minus 216. Now it's cubes, so I know I'm going to be using either sum of cubes or difference of cubes. And in this case, it's a difference because of that minus, okay? So before we get started, and something that's going to help you and simplify your problem is you always want to look for the greatest common factor. Can you take out anything that they have in common, okay? So in this case, I can take out an 8 from both of them, leaving me with x cubed minus 27, okay? This 8 is going to be part of my final answer once I figure out my factors, because I factored it out. I'm done with it. So now I can focus on just what's inside my parentheses. Inside my parentheses, I have x cubed minus 27. So my A is x, and my B is, oh, not 27. What cubed would give me 27? So if you go through, or you can use your calculator again, you're doing 27 cubed. That's going to give me a 3, okay? So I'm going to write down my formula for difference of cubes. So difference of cubes, it's A cubed minus B cubed equals A minus B, A squared plus AB plus B squared. Okay, so now that I know what my A and my B are, it's just substituting into this. So A is x, B is 3, x squared plus, again, A times B would be the same thing as 3x. And then B squared is 3 squared, so that would be a 9. Okay, so this is my answer, not forgetting the 8 in the front. So because I wrote it down here, I'm just going to fill it in. You're always going to go back and see, can you factor this any further? Can you factor x squared plus 3x plus 9? No, you can't, because two numbers don't multiply to 9 but add up to 3. So then this is your final answer. If you don't take out the 8 at the beginning, that's okay. Hopefully, once you go through and factor it, you'll see that you can take out another number in common. But it's easier if you recognize that from the beginning. Okay? So always check for greatest common factor before you start using the special factoring. So for example, here on number 5, I run into a problem that just looking at the exponents, neither of those are squared or cubed. So I have to do a little bit more. So if I look at taking out a greatest common factor, well, 16 and 250, I'm going to start with 2. They have a 2 in common. And then how many x's can you take out from x to the 5th and x squared? You can take out 2 of them. When I take out a 2x squared, inside I'm left with 8, 3x's minus, and then just 125, okay? So again, this 2x squared is going to be part of your final factoring once you get there. And now I can focus on just what's inside the parentheses. So this is going to be a difference of cubes. My a is going to be, okay, so breaking down 8x cubed, I know that x is going to be part of it. What number multiplied by itself 3 times gives me 8? I'm hoping you're thinking 2 there. And then 125. So 125 multiplied by itself, what number multiplied by itself 3 times gives me that? And that would be 5. So using my formula of difference of squares, I have a cubed minus b cubed is a minus b, a squared plus ab plus b squared. Okay, so I can now, because I know what a and b are, substitute into this. So 2x minus 5. Okay, so here's where it gets tricky. I have a squared. So what is 2x squared? You have to square both of those terms, right? So 2 squared is 4, and then x squared plus a times b. So what's 2x times 5? So you have to write 10x. And then b squared. So 5 squared is 25. Okay. So then I look at my factoring here. Is there anything I can factor out any further from this one or even this one? So I think about 2. If I multiply, I get 100. So anything that multiplies to 100 but adds up to 10, nothing really comes to mind. So I know I'm done, not forgetting about that 2x squared I originally took out as my greatest common factor. Okay, and here is my final answer. Okay, and the last one before we do our word problem, we have 4x to the 4th plus 25. So I have a sum, and this looks more like a perfect square, okay? So a is going to be what number multiplied by itself 2 times gives me 4x squared. Well, 4x squared can be broken down to 2 times 2, x times x. So I'm thinking 2x here. And b, the 25, would be 5. So my sum of squares, a squared plus b squared, factors out to 8 minus bi times, a plus bi. So now it's just substituting into this factoring. So I have 2x minus b is 5i, and then 2x plus 5i. There's nothing else I can really factor out here, so then this is going to be my final answer. Okay. All right, last problem. If a cubed plus b cubed equals this formula that we've just been working with, then what is equivalent to 64x to the 6th plus 27y to the 12th? Okay, so essentially I'm telling you to factor this using this formula. That's what this problem is telling you essentially. So you first have to see if you can take anything out. In this case, I can't. There's nothing that 64 and 27 have in common. So I have to figure out, using 64x to the 6th, how can I break this down to be a cube? Okay, so for the 64, you can use your calculator. You can go cube root of 64, and that's going to give you 4. When you do the cube root of x to the 6th, think back on your exponent properties, where you have 6 over 3. Remember, in and out, this is my in, this is my out, and so I write it that way. So 6 divided by 3 comes out to 2. So my a is 4x squared. Because if I were to cube that, if I were to raise this to the third power, I would get this. Okay? Just so you understand where that came from. Okay. Now I'm going to do the same thing with my second part. So 27y to the 12th. Again, I can use my calculator for the 27. The cube root of 27 is going to be 3. And then if I use my exponent properties, I know that cube root of y to the 12th is going to give me y to the 4th. So my b is going to be y to the 4th. So now it's just using my property, which is given to me here, and simplifying. So this is going to require a little bit more simplifying than before. So first I'm going to write a plus b. So a is 4x squared plus b is y to the 4th. Okay. And then I'm going to break these up a little bit different than I did before, just because I want to make sure we don't mess up. So a squared for me is going to be 4x squared squared. Okay, I'm going to keep going. Then I have a minus ab. So minus a is 4x squared times b is y to the 4th. Keep going. Plus b squared. For me, b is y to the 4th, and then I'm going to square that. Okay, so I'm substituting, but this time I'm just taking it a little bit slower. And here, I actually forgot the 3 in front, which is going to make a huge difference. So I need the 3 there and the 3 there. Sorry, let's go back and fix that. Okay, so now I have to simplify everything inside. This first set of parentheses is not going to simplify at all, okay? I just still have a 4x squared and a 3, I forgot the 3 there too, y to the 4th. Then I go inside this parentheses. So I am going to go ahead and distribute the squared. 4 squared is 16. X squared squared becomes x to the 4th. Minus, I'm going to keep going here. I'm going to multiply number times number. So 4 times 3 is 12. And then the x squared and the y squared can't combine. So I'm just going to leave those there. And lastly, I have a plus. And this is why that 3 is really important, because I forgot it originally. I would have gotten this part wrong. So 3 squared gives me a 9. And then y to the 4th squared, your exponent properties tell you that you're going to multiply those. So this becomes y to the 8th. Okay, so now that you've simplified everything inside, this is what this would factor out to. And that is the end of your notes.